let's see if rewriting number 5 may help us. I'm going to factor out a 3 to get x squared. So divide by 3 to get a 1, divide by 3 to get a 2, divide by 3 to get an 8. And then I'm going to factor out a 2 to get x squared minus 9. Now this is where your factoring skills really play a key factor in being able to accurately graph this with no graphing device. X squared minus 9 factors into x minus 3 and x plus 3. And now this factors into x minus 4 and x plus 2. Now this is going to be pretty easy. When I identify a horizontal asymptote, if it even exists, I'm going to look at the degree in the numerator and the degree in the denominator. Since they are equivalent, then I'm able to create a ratio of the leading coefficient in the numerator divided by the leading coefficient in the denominator. So the horizontal asymptote is y equals 3/2, which is equivalent to 1.5. So I'm going to come to 1.5 and make my dotted line. And now when I look at the vertical asymptotes, it's going to set each one of these quantities equal to 0 to get x equals 3 and x equals negative 3. Remember that our function can touch or cross a horizontal asymptote, but it will never touch or cross a vertical asymptote. How do we determine the y-intercept? Another thing we have to algebraically identify. So when we find the y-intercept, our x is always 0. So 0, 0, I have negative 24, and 0 over negative 18. Well, two negatives make a positive, and let's see, these are both divisible by 6. Divide by 6 to get 4, divide by 6 to get 3, and I have 4/3. Now, we know 4/3 is just slightly greater than 1. 1 and 1/3, actually. So 4/3. So 0, and here's 1 and 1/3. Okay, remember that this line was at 1.5, or it should have been, so it's just right below that point. Now, is it possible that this has an x-intercept? It does. If there's any variable in the numerator, we're going to take those two quantities and we're going to set them equal to 0. That gives us an x-intercept at x equals 4 and another x-intercept at x equals negative 2. So 1, 2, 3, 4, and also at negative 2. Now, how do we go about creating this so we can have a graph? So we can have a graph of this. Like, how do we know if this makes like a U shape down? The nice thing is we already have one point here. I already know just by patterns that it looks like this, but how do we know what this looks like? Well, I'm going to choose another number to the right. Like, I'm going to choose positive 1, and let's see what we get for an outcome. So I know there's not much room here, but I'm going to choose positive 1. So x equals 1. And I'm going to substitute in. I think it's easier to substitute in here. Let's figure out what is the outcome. What is the y value? So I have 3. Okay, I'm going to substitute in 1. So 1 minus 4 is negative 3. Substitute in 1, I get a positive 3. Come down here, substitute in 1, I get a negative 2. Substitute in 1, I get a 4. So I have negative 27 on top, and 8 times 2 is a negative 16. So 27 divided by 16, well, that's going to give me a little bit greater than 1.5. I just use a quick calculator to get it's about 1.6. It's a positive 1.6 approximately. So if I come here, I'm going to go up to 1.6. What does this share with me now? Well, it shares with me that we have a shape that's looking like this. So it's coming up this way and coming down here. Now I just need to know, is this above or below this horizontal asymptote of 3/2 or 1.5? So let's choose the number directly to the left of this vertical asymptote. This is 1, 2, 3. Let's choose negative 4. So I'm going to flip this paper over. And let's try when x is at negative 4. Okay, so I'm going to come back here because I think it's easier than working with this one. And we have 3. I'm plugging in negative 4 to get negative 8. Plugging in negative 4 to get negative 2. Plugging in negative 4 to get negative 7. Plugging in negative 4 to come up with negative 1. All right, well, let's see. Can we simplify? It's going to give us a negative 1 when we simplify. And so I multiply here to end up with a positive 24 and multiply here to get a positive 7. So 24 divided by 7. Well, 21 divided by 7 is 3. This is a little bit greater. So this is going to be just a little bit greater than 3. So if I go over to negative 4, I need to go up a little bit more than 3. 1, 2, 3, a little bit greater than 3. And all that shares with me then is this basic shape. It tells me that this portion of the rational function is going to be up here in this section.